transmissions. Electronic automatic transmissions. What can you tell me about them?
It's run by a computer, right?
Pretty much. So, do you know the solenoids, the transmission solenoids, like the one in Abby's transmission that we're working on there? How do they operate? You got any idea? I mean, you got several solenoids in there.
Looking at them today, or yesterday, I mean, and they seem to have these two electronic prongs on them that were spaced a certain width apart. I was wondering if maybe they function by conductivity or something, or
well, it's a solenoid, Sean. And what you got is whenever you power and ground it, there's going to be power going to it. On Nissan transmissions, they're hardwired to ground, and the computer shoots power out to them, which is totally antithetical to the way we're used to things happening. It's kind of like on the air springs on these Lincolns and stuff. They're hardwired to ground, and the computer shoots power out to them, which is backwards because we're used to our injectors getting and everything else getting the ground while it's hardwired to power. All right, that's the way those operate. So basically, what we got here, let's see. We got these. We're going to just wing this thing through the electronic pressure control solenoid. This is sort of a test. It's like a short answer test, and so it's not really multiple choice. But we're going to go through this thing. The electronic pressure control solenoid is basically, you got to have pressure control, right, in the transmission. And we talked about a pressure control valve before. You know how that works? Pressure control valve basically works.
Like a fluid manifold that I showed you yesterday.
Well, it's vaguely. What you got is you got a spring and you got a piston. And whenever the pressure pushes that thing up, it actually opens up a port whenever it's moved at a certain distance. And it's going to dump that pressure. But it has to apply a certain amount of pressure to move it that far so it can dump it. That's the old pressure control valve. Electronic pressure control valve is a variable force solenoid. Now, you've seen the idle air control on our these Fords. Basically, the more current you apply to it, the more it moves that little plunger, right? That's just the way that works. The more it's like a plunger in a spring. And the electronic pressure control, the way that operates is the more current it applies, the lower the pressure goes. Now you got it's where it defaults to high. We talked about that a little bit before. If for some reason you lost connection going to the pressure control, it defaults to high pressure, and that saves the transmission from slipping clutches and burning itself up. You got me? So basically, what you're going to do, the electronic pressure control solenoid, is what the computer uses. They'll have a transducer giving it feedback typically, and it's going to change the fluid pressure as is needed based on your throttle. So if your throttle position sensor is going to, in the map sensor or mass airflow, is going to give you the load information. It's going to tell it where that pressure needs to be, and if you're into it really heavy, the pressure needs to be high. You got me? So the line pressure has got to be higher on that way. Transmission fluid temperature sensor signal is used by the PCM to what? And don't say to determine transmission fluid temperature, right? It's basically going to modify the pressures and things based on the temperature of the fluid. And furthermore, if it's cold, if the transmission is cold, the lockup converter will not work.
I figured that the viscosity varies with temperature. The PCM uses this info to make shift adjustments.
Yeah, it's basically going to change the way that it handles the fluid when it's cold and thicker and all that. Also, transmission fluid, the difference, and I've said this before, the difference between transmission fluid and motor oil is transmission fluid is going to be lower on the stick when the engine is cold, when the whole car is cold. And when you crank it up and it warms up, it's going to expand and come up the stick. Right? You got that? All right. If there's no signal in the EPC circuit, or if the PCM has no control over the signal, the EPC solenoid is designed to, what did I say before? The pressure is going to go high. It's going to maximize the pressure. All right. Well, we got that right there. All right. Let me make sure I'm on the right page here. And we only got 10 questions here anyway. This is kind of a short one. Okay, now that one right there, number 4, the PCM uses vehicle speed sensor and output shaft sensor and turbine speed sensor information for what purpose? What does it do that? What does it do that? Well, yes, that's part of it. Torque converter clutch operation, and it also uses that, believe it or not, for EPC pressure. You know, it's a feedback for EPC pressure, so it'll know what to do with EPC pressure, electronic pressure control pressure, and all that. So now you might also note that the vehicle speed sensor is where it's looking at the drive shaft, how fast the vehicle's going. The turbine speed sensor is what they say output shaft sensor, because the Daniel, on Abby's transmission, you know, that sensor that's basically in the that cover that's reading off that wheel on that sprocket, you know, that's basically an output shaft sensor. It's basically telling the computer how fast the output's turning. It also knows how fast the input's turning. It knows what gear it ought to be in. I mean, it knows how those speeds ought to compare if it's in a certain gear. And if it doesn't see the gear that it, you know, if it sees that the engine is turning really fast and the output is turning really slow and it's in fourth gear and it knows it ought to be at road speed, it's going to, you know, tell you there's a problem. It also can determine if there's slippage. If the torque converter is fully locked and you're in 1-to-1 and the engine, we used to try to see if our torque converter was slipping by doing this. Watch this. You get up here, you get to where your tachometer and your speedometer are tracking together. You're basically in lockup, and you got it in a high gear. Well, I say high gear. You got it in 1-to-1, you know, which is third in a lot of cases. All right, so you're going to crowd the throttle just a little bit, not so that it'll downshift, but so that you'll actually be putting a little strain on it. And if the engine starts gaining on the vehicle speed, you know that the torque converter is slipping or something's slipping. Got me? Now, before the PCM started paying any attention to the turbine shaft and all that stuff, you know, some of them have got 3 sensors in there. They're looking at what's coming in, they're looking at what's going on in the middle, and they're looking at what's going out the back. And they're comparing all that so they can get a better idea. The computer can give you more of an idea of exactly, you know, where you need to be looking for your trouble. But anyway, that's an electronic transmission thing. Okay, number 5. If the PCM detects that the transmission has been shifted into reverse when the vehicle is traveling in the forward position, what action does it take? That's a smart son of a gun. What it does is, write this down, it turns on shift solenoid 1 to move the 1-2 shift valve in order to block the reverse hydraulic circuit and exhaust pressure so the transmission will not go into reverse.
Yeah. What?
That's on a forward now. If you throw it in reverse, it keeps it from going in reverse. Just because you put it in reverse, and you're going forward at a high rate of speed, the transmission says, this guy's an idiot. I'm not going to let this thing go into reverse. Now, what was funny was my 95 Taurus, if I put that thing in reverse, one time, how many of you guys have ever been driving on the interstate and found out you took the wrong exit? And say, crud, I wasn't supposed to take that exit. I do not want to go 20 miles before I can turn around and go back. And so you stop before you're very far up the exit, and you hope there's no cops around, and you throw it in reverse, and you back down there, and then you zoom on out, right? So I was over in Savannah area, over other side of Georgia, over close to the Atlantic Ocean, and I threw my Taurus in reverse. I'm getting you some more ring terminals too, by the way. But I threw my Taurus in reverse, and when I went to back up on it, my 95 Taurus, it felt like it was losing fuel pressure or cutting out for some reason. I said, wow, something's wrong with my car. But whenever I put it in forward gear, it was fine. It would not let me drive more than about 25 miles an hour in reverse because they're afraid you're going to crash into something. You know, there's some issues with that back in the early 90s where some Audis, you remember heard about them Audis that they put them in put them in reverse, and they take off backwards, they run into stuff and everything, and they try to act like there's something wrong with the car. Well, every single one of those was driver error. An independent study revealed it was driver error. You put your foot on the gas, you put it in reverse, it starts off back, it throws you against the gas pedal, and you can't get off of it. And it just gets faster and faster and faster, and it was your foot on the gas pedal. So what they do, they made it where you had to put your foot on the brake before you could shift it out of park. That's the way it is now. And that's the reason for it, because some people were goofy enough where they put their foot on the gas, throw it in reverse, it would take off in reverse and throw them against the gas pedal, and it was just a snowball situation, see? And every one of them was them doing it. One time I got a Jeep over there that brought in on the hook from up there, up around Luverne somewhere. I mean, it came all the way to Dothan. I'm not driving this Jeep. It tried to run away on me. And then when I cranked it up, I ain't driving it no more until you guarantee me it won't do that again. And so nobody touched it since he got in it, and it did that, and it came down there, and they set it down, and I looked, and the gas pedal was stuck under the floor mat. Was that the vehicle's fault? He didn't even look down there. He just blamed it on the vehicle and had it towed all the way to Bundy. Well, he had to pay a record bill.
Instance with Priuses like 2 years back where all the floor mats was sticking on causing people like to wreck.
They were
They did
actually,
recall on
to
that.
fix that, they actually changed the throttle pedal assembly and did some things to put a different, or something. I mean, Snap was working at Toyota when they did that, when they were going through those recalls. You know, they would shim the gas pedals, and it had something to do with what you're talking about, I guess. But anyway, the long and short of it is, all right, let me see here. Number 6, how can a faulty engine coolant temperature sensor reading affect transmission shift strategy? That's an interesting question, isn't it? If it may command the transmission to operate on a cold shift schedule, which is different from a warm shift schedule, to cause the transmission to shift differently. Now that was actually engine coolant temperature, not transmission oil temperature, right? Something else I've said earlier that you guys might want to pay attention to. Let's say that you're thinking maybe my transmission oil temperature sensor or my engine coolant temperature sensor or my intake air temperature sensor are not reading right. I'm going to plug my scan tool in after that thing's been sitting out in the lot all night, or maybe even sitting in the shop all night, and I'm going to compare those 3 temperature readings on my data stream, and they ought to be within a degree of each other because of the second law of thermodynamics. You know, everything sort of levels out. All right, now if nothing's creating heat, it ought to go all the same place. If one of them is reading out of kilter, then something's wrong with that sensor. You got me? Or the circuit. Okay, so number 6. Now number 7. What does the PCM use electronic ignition system data for? In other words, how does it do that? It uses it for electronic pressure control, shift scheduling, torque converter clutch apply and release control, wide open throttle shift control. All those things, you see, is basically using it for that. Electronic ignition system data, it knows when you're at wide open throttle. Now, something else that it does, and let me explain this a little bit because this is really important that you get this. Now, you guys are, you know, torque converter lockups for gas mileage, right? That's why they do that. They want a straight hookup all the way from the engine all the way back to the back wheels. Because if there's no slippage in that torque converter, everything your engine's doing is being sent to the back. You got me? That's what torque converter. It goes into torque converter lockup in 3rd gear. 3rd gear and 4th gear and torque converter lockup are 3 different things. You can be in 3rd gear without the torque converter lockup. You can be in 4th gear without torque converter lockup. You can be in either one of those gears with torque converter lockup, but torque converter lockup is not going to happen in any gear below 3rd typically. Got me? And on a lot of vehicles, if you're driving down the road and you just want to see if your torque converter is locking up, not on every vehicle because some of them don't do this, if you tap the brake, it releases the torque converter. So you're driving down the road, you're running about 1,600 RPM, and you're running 55 miles an hour or whatever, and you just hold your gas pedal where it is and watch your tachometer, tap the brake with your other foot and see if it picks up some speed and then drops back. You'll know your torque converter's lockup's working, usually. Now on some vehicles, tapping the brake won't make it drop out.
You don't got a tachometer in your gauge.
Well, you're going to have to find a way to read vehicle speed with something else. You can pull a tachometer in there with you, you know, scan tool, whatever. But the long and the short of it is, what it'll do on these newer vehicles, it actually causes remember I told you this before, I think, but I'm going to say it again, that the torque converter doesn't lock up just a straight lockup as soon as it goes. It goes 20%, 30%, 40%, 50, 60, 70, and you can look on your scan tool and see what percentage of converter lockup's being engaged. See what I mean? It actually acts like I had one time was on an 89 Eagle Summit. I hooked a dwell meter up to the torque converter, and a dwell meter basically is what you put on a distributor to see how long the points are closed, and I could actually tell that it was, you know, doing that. And when I first came back and told my shop foreman, I said, this is not a straight lockup torque converter, it's actually locking it up in percentages until it gets all the way locked up. When it's 100%, it's all the way locked up. Well, when it's in this 50% range, and the friction modifiers, that's just, you know, the stuff here that they, you know, kind of like this, that they put in the, you know, that smelly stuff I sent around? All right, that stuff is in the fluid. It's supposed to, when it's at a partial lockup, it's supposed to slip smoothly. It's going to be a controlled slip. Well, if the friction modifiers have worn out, it's going to surge and feel strange. And if you disengage, if you disable the torque converter lockup, however you decide to do it, and it doesn't surge, you know then that it's not in the engine, it's a transmission issue. Okay, so some people will work and work and work on an EGR problem before they ever found that. All right, now then, the PCM, let's see, let me see here. The PCM, excuse me, let me answer this. Hello. Hey. Yeah. I haven't seen any pictures on those yet. Yep. I don't want to spend that much. Just send me a jumper box. You know, like a 1300 amp jumper box that you hold like a suitcase. Yeah, I don't want. Yeah. Yeah, three. Well, I don't want to go quite that big. I'm willing to spend probably 160 bucks or something like that, maybe 180. But no, I don't want to spend $350 on one of them. Yeah. All right. Okay. Now then, we got a number 8. How does operating a 4-wheel drive vehicle and 4x4 low affect our PCM's control of the transmission? Did I tell you about this before?
No. The transfer case changes the pressure.
If you operate it in 4x4 low, the PCM is going to know it, and it's going to cause it to shift into high gear before you even going 20 miles an hour. Now, this is another thing. If for some reason the power that's feeding that 4x4 low light has been removed, like if the fuse is blown or something, and the engine controller will assume, because of the way that thing's wired up, that it's in 4x4 low, when it's not. You'll be trying to just drive normally, and it will think that light's lit up because there's no voltage. Like if the transfer case grounds that light and turns it on, right? And the PCM's looking at that line. If the PCM doesn't see 12 volts on that line, it assumes that that light is illuminated and you're in 4x4 low. That's the only input it has on the older vehicles. Now the newer ones are going to be different because they got a body computer and all this kind of stuff. But long and short of it, I saw a guy rebuild a transmission because of a blown fuse. Because it would shift all the way into the highest gear before he even got going 20 miles an hour. And after he got, smacked around a little bit, he calls for the calf rope. I mean, I don't have all the answers, but for some reason they always call me. And I went over there and I said, well, I don't even see any of these indicator lights working. He goes, I ain't worried about that. I'm working on the transmission. I said, well, wait a minute. One of them is the 4x4 low light. Did you think about that? Ah. So we put a fuse in there and woke those lights up, and now all of a sudden he had normal shift scheduling. See what I'm saying? See how much trouble you can get into if you don't understand this? There's another thing. Is a girl that was in here, Alicia. It was funny as all get out. I mentioned that before. She says, she called me. She says, my transmission's in high gear every time I try to take off. And I said, check the fuses. She's over called me from the house, and her daddy was over. She was in my program at the time. And I said, check the fuses. So her daddy says, oh, that's the stupidest fool thing I've ever heard of. Well, she just sort of pushed him out of the way, and she checked the fuses, found one blown, put it in there, and she had normal transmission. Well, if the solenoids aren't operational, it's going to go that route. But anyway, what does it cost to check the fuses anyway? You know what I mean? Hey, where's the ring terminals at? Oh, you got them in that bag? Throw them at him. Okay, we're almost done here. We're going to be going to lunch in just a minute. What else you got here for me? Washer fluid. You guys know what happens to the washer fluid? Sitting out there? All right, put them other tickets on my desk if you don't mind, please, Sharon. All right. Yeah, we're just about done, guys. How does the air conditioner clutch operation affect the PCM's control of the transmission? What do you think?
Yeah.
In response to AC clutch operation, the PCM adjusts EPC pressure for the additional load on the engine. Right? It adjusts torque converter clutch modulation and shift scheduling. Modulation is what I was talking about with these different percentages. And finally, number 10, what is the difference between a digital transmission range sensor and an analog transmission range sensor? Now that's one I was talking to Daniel and Mr. Webb about yesterday. And that is the digital transmission range sensor sends a digital signal to the BC. What's a digital signal versus an analog signal? What the signal looks like. One of them acts like a throttle position sensor, and if you click it through while you got a scope hooked up, it's going to look like stair steps. Like that. Now that looks digital, don't it? But it's not. If you've got a digital transmission range sensor, you're going to have, about binary code?
0, 1, 0, 1, 0,
all right, there's 4, exactly. There's 4.
Anomaly 2.
Yeah, well, if you got if off is 0 and on is 1, right? Mm-hmm. So you're going to have 4 different switches in that thing, and they've got various different offs and ons. And do you know how to read binary code?
No.
Did you ever learn that? One time I was talking about binary code in here because I was set some dip switches in the thing I was putting in a computer, and one of these guys said, "What's binary code?" And Christina, the little homeschool girl I had in here, she goes, "I can explain that." And she got up here and did it on the board, and just blew me away. But anyway, the long and the short of it is, it's going to start out with 1, 2, 4, 8. Got me? Okay, if this one here is on and that one there is on, that's the value of that is 10. Got me? 8 and 2. All right, so if this one here is on and that one there is on, I mean if they're ones, that's 5. Real simple. So the computer knows as it looks at that digital transmission range, and there's just 4 places. You know, the 8-bit binary, this is a bit. Each one of these is a bit, right? Okay, in a computer code, 8 bits is a byte. A byte's like a word, and a bit's like a letter. You got me? That's how that works. So anytime you talk about computer movement, you know, like how many KBS or MBS you're getting, that's bits, not bytes. You're multiplying it by a factor of 8 when you say byte instead of bit. So if it's 500 megabits per second, you're talking about 500 letters, not 500 words.
What about those 8-bit systems?
Yeah, this is a 4-bit thing, but it's coming. You can see in a transmission range sensor, there's 4 switches in there, and each one of them's an on and off switch, and different ones of them are on and off depending on what gear you're in. Got me? And the other one's got like a TP sensor, but the difference is you're going click, click, click instead of, you know, moving through a range smoothly. All right, everybody got that?
Analog is more like a pulsated electrical pulse.
Analog is like turning the. Have you ever turned the? You ever turn the knob on your light and seen them go down and up slowly?
Yeah.
Like, you know, that's an analog. This is digital, off or on, nothing in between.
Yeah.
See?
High and low, 1 and 0.
Yeah, 1 and 0. That's right.
The
Yeah.
Andalusia pickups out there for you to inspect at your convenience. A brand new set of jumper cables on the floor. They said to keep track of them. That's what they look
Have
like.
they been having to? Have you been having to jump it off?
No, but it looks like they bought a pair. It looked like a laptop, so I picked it up. Looked at it. Just a new set of cables.
Well, nothing's gonna happen to
Find
that.
your next Joe.
You got it, man. All right, we're done, guys. What do you think?